The need for organs and tissues available for transplantation far exceeds their availability. More than 100,000 patients can be found on the donor waiting list at any given time. An average of 22 people die each day while waiting for a donor organ or tissue to become available. To meet the demand, scientists have tried to create artificial organs through innovations such as 3D printing tissue. So far, however, no one has been able to print a perfect heart. One of the big problems in engineering heart muscle is getting flow to all of the cells. It's notoriously difficult to build a working network of fine blood vessels, especially when you get down to capillaries, which are only 5 to 10 micrometers wide. Current technology cannot construct tissue dense enough to replace a damaged heart, while also allowing for the tiny blood vessel needed to deliver life-giving oxygen. A team led by scientists from Worcester Polytechnic Institute have successfully turned a spinach leaf into living heart tissue.
So we take spinach leaves and we perfuse them with a detergent that removes all the cellular material from the spinach leaf. What we're left with is the structure that keeps those cells in place.
Plants and animals exploit fundamentally different approaches to transporting fluids, chemicals, and macromolecules, yet there are surprising similarities in their vascular network structures.
And so the idea here is we have this very thin, flat piece of tissue that already has that vascular network in there, and so we should be able to potentially stack up multiple leaves and create a piece of cardiac tissue.
At day 1, the leaf loses some of its dark coloring and begins to appear translucent. By day 5, the leaf is completely translucent while maintaining a light green hue. After being treated and sterilized with sodium chloride, the leaf loses the remainder of its coloring and becomes completely decellularized on day 7. This leaves behind the protein matrix and structure. Left behind was cellulose, a plant material known to be compatible with mammal tissue, as well as the intact leaf veins.
Techniques can't fabricate microvasculature the way that the body needs it. So without that microvasculature, you lose that oxygen transport, and so as you build a bigger and bigger graft for, say, like a heart attack on a human, you're going to need something fairly large. So without that vascular network, you get a lot of tissue death.
The scientists seeded the now vacated cellulose matrix with cardiac muscle cells. Human umbilical vein endothelial cells were seeded within a vein of a decellularized spinach leaf by perfusion. And the human mesenchymal stem cells were labeled with quantum dots and seeded onto the surface of a decellularized spinach leaf. After 5 days, the heart cells started to spontaneously contract just like they would in human tissue.
We really believe that this scaffold has the capability to help treat patients. It's still a long ways away, but to think about combining the technology that farmers have been using for thousands of years and growing different crops in the field, to be able to just take something as simple as a spinach leaf, which is an abundant plant, and actually turn that into a tissue that has the potential for blood to flow through it is really very, very exciting, and we hope it's going to be a significant advancement in the field.